Welcome or welcome back at C-Squared. In this lesson we will talk about secants, and you see here the definition of a secant is a line, ray, or a chord that intersect a circle in 2 points. Like in this case, you notice we have the secant AB. Two secants can intersect, you see here in this case, inside of the circle, and they form some angles. I'm going to look to this angle, CEA. This angle, and you notice here the formula, that angle is equal with the sum of these two arcs BD and AC and divide by 2. Okay, don't forget to divide by 2. Okay, this is the theorem which says that angle its form is half the sum of the measure of the intercept arcs. Very similar we have when two secants intersect outside of the circle. We have this angle, for example, BD. Well, of course, you can call it AEC. That will be okay. This angle is equal with the difference. So, but be careful. You start with the largest one of the intercept arc. That's what this theorem says here. So let's see the first example here. We have to find the measure of angle 1 in these two problems, A and B. And in the first problem, A, we notice the measure of arc AD, this one is 66 degrees, and the measure of arc BC, it's 54 degrees, this one. So for finding the measure of angle 1, we just simply add these two arcs, 66 and 54, and divide by 2. That will be 120, divide by 2, that will be 60 degrees. The measure of angle 1, in this case, the angle formed by these two secants inside of the circle is 60 degrees. Let's take a look to part B. Very similar, however, in this case, angle 1, this one, it's formed by the two secants and is outside of the circle. So if you remember, the measure of that angle 1 will be the difference of the intercept arc. So let's take a look. Do we have them? Yes. The measure of arc BD is 120, this arc. The measure of arc AC, it's 20. So we're just going to subtract them and divide by 2. So we have here 100 divided by 2, that will be 50 degrees. There are two more cases. You notice the first case here, we have a secant and a tangent, but you notice the formula is very similar, is the same in fact with the one we had before. Just be careful to the intercept arc. In this case, DC and DB we subtract. And we have this case, the second case, two tangents. In this case, they form also two intercept arcs. Be careful of these two intercept arcs. The sum of these two intercept arcs is 360 degrees. That's good to know. You'll see it. You subtract them and divide by 2. So let's see an example. In fact, two examples, A and B. Let's start with A, where we have to find the measure of angle 1. And we know BC is the measure of arc BC, it's 64, this one, which is an intercept arc, you notice. And the measure of arc DC, this one is 112 degrees. So, but you notice we have to do one extra step here because we do not know the measure of this arc, DB. But we can find it, right? Because we can add 112 and 64. We can add those two arcs. And that will be 176. And subtract this 176 from 360. How much is the measure of the whole circle? 360 degrees if you go around. So 360 minus 176 is 184. That is the measure of this intercept arc BD. So now we can find the measure of angle 1 by simply doing 184 minus 64, the two intersect arc, divide by 2. So that will be 120 divided by 2. That will be 60 degrees. Let's take a look to part B, where we have to find the measure of angle 1 still. And we know this BC here is 130 degrees. This is one of the intercept arc. We need to find the second one, the major arc, BDC. And that one will be 360 degrees, the whole circle, minus 130. That will be 230 degrees. Now we can move to the second part of the problem, where we can find the angle. Measure of angle 1 will be 230 minus 130. So you see the difference of two intercept arc. Don't forget to divide by 2. So that will be 100 divided by 2, and that will be 50 degrees. That is the measure of angle 1 in this case. Sometimes you have to go backwards and find the measure of an arc. Like in this case, find the measure of arc FD. I should have this arc here. If the measure of angle CGB, this one, is 92 degrees, and the measure of arc BC is 62 degrees. So we know this arc also. So here what can we do? I'm going to write the formula. The measure of arc of the angle, BGC, that angle formed by the two secants inside of the circle, is equal to the measure of arc FD plus the measure of arc CB divided by 2. And here we're gonna replace what we know. We know angle BGC or CGB is the same thing, 92 degrees. We know the measure of arc FD. No, that's what we need to find out. So I can call it simple X plus the measure of angle of arc CB, that's 62 over 2. So now we have an equation, many ways to solve it. I will suggest you to multiply by 2 to get rid of the denominator. So we have 2 times 92, 184 equals X plus 62. The last step to find X, subtract 62. And we have X equals 122. That X is nothing else than arc, the measure of arc FD, the one we're looking for. So you notice here we replace the value and we end up with an equation and solve it. Very similar in this problem, the only difference, now we know the measure of angle C. This isn't the angle formed by the two secants outside of the circle. 42 degrees, this angle. Then we need to find this arc EF, and we know DB. This one is 116. So I'm gonna go and write the equation right away. The measure of the angle C, which is 42 degrees, equal with the difference of what? 116, the largest intercept arc, minus X over 2. And very similar, we're gonna solve the problem. We're gonna multiply by 2. I erase the degrees to get rid of these two. Don't forget to multiply by 2 on the other side. 2 times 42 is 84 equals 116 minus x. I will subtract 116 here, and I will have 84 minus 116. That will be 32, negative 32, be careful, equals negative x. So x will be 32. What is that x? If you remember, that's how we can call the measure of arc EF, the one we're looking for. So that arc is 32 degrees. You notice here I have another situation where a tangent and a secant intersect right there on point A, and we get two angles. We get this angle and this angle. We have also a theorem that will help us to find these angles. So you notice the measure of angle BAC. This one is half of this arc AC, and for the other one, very similar. The measure of this angle is half of this major arc ADC. They both are intercept arcs. So that is the theorem. If a secant and tangent intersect at a point of tangency, then the measure of the angle is 1/2 the measure of its intercept arc. So let's see here these two examples. We need to find the measure of angle A. We go back, the measure of angle A, this angle. And for that reason, we're looking, do we have the intercept arc? We do. Is this 152 degrees? So very simple in this case, the measure of angle A will be nothing else than 152, that intercept arc divided by 2, and that will be 76 degrees. Now on this part B, we need to find the measure of an arc DGF, this arc. So for that reason, I'm gonna look first to this angle D. We can call it simple like that. The measure of angle D, if you notice, is 68. So the measure of arc DF, this one, you notice I use only 2 letters because it's the minor arc, is going to be double that 68. It's going to be 2 times 68, and that will be 136 degrees. That is how much this arc here is. So we have to do one more step to find the measure of the arc DGF, this arc. We just have to do 360 degrees, the whole circle, minus 136, the minor arc. And that will be 224. So the measure of the arc DGF is 224 degrees. On this second part of the lesson, we're going to look to this special relationship for segment lengths of two chords when the chords intersect. And you see here you have a picture. You see 3 chords intersecting in this point A. I'm going to make it simpler. like this one, you see two chords. We don't have the chord F, C, and you notice the relationship between the parts formed when this secant intersect is right here. For a given point and circle, the product of the lengths of two segments from the point to the circle is constant. So you notice we start from this point A, from so AG times AD. So that's what it says here. From the point to the circle, it's the same with AE times AB. By the way, it works also for the other secant F, AF and AC. I can put that also here. AF times AC. So once you have something like this, you can write this property, this using this theorem. Okay, so let's take a look to these two examples. On this part A, we need to find AG, so I'm going to call this X. And you notice here now, I'm going to use the property AG, which is X. I'm going to start with X. Times what? Times AD. You see how this property works, which is 9 equals what? Now AE, that is 3, times AB, that is 6. So I just applied the theorem we discussed about. I want to solve for X, so I'm going to divide by 9. And here I have X equals 3 times 6, 18, divided by 9 is just 2. That is how much AG is. Very similar for the second problem. The only difference, we have some expression, but it's the same way. I'm going to start with this one. KV, which is X minus 1. So I'm going to use the parentheses here. Times KR. So you see, you start from the point and you go to the circumference. And KR is 4 equal what? Let's do KF, which is 2x minus 4. Again, use parentheses. Times KP, which is 3. So you notice now we end up with an equation. I will use distributive property here, and I will have 4x minus 4 equals 3 times 2x, that's it, 6x minus 12. I will subtract 4x, and we have here negative 4 equals 2x minus 12, add 12, and we have 2x equals negative 4 plus 12 is 8, divide by 2x equals 4. Well, we are not done because we need to find the length of KV. KV, it is x minus 1, so you have 4 minus 1, so KV is 3. Very similar, we have a relationship for two secants that, or three secants you see in the first picture, they intersect outside of the circle. So look at here, I'm going to show you how it looks when you have two secants, in this case AC and AE. Notice you want to start from the point A, and you have AF times AC equals AE times AD. So it's the same property like the other one, the only difference you are outside of the circle. So now I'm going to put here also equals what? If we look to this picture, here you need to be careful, it's going to be equals AB squared, in case you need something like that. So this is the theorem, and you see it's the same theorem. So let's see this example, and we're going to start with part A. where you need to find the measure of DE. I'm going to call this X. Now here you need to be careful. So you always start from the point. So let's start from this point, and the first thing I'm going to do AE, which is 3, times what? Now is not DE. Be careful, it's not DE, it's AD, which is going to be X plus 3 equals, now we move on the other side and we have AF, which is 4 times AC. Now that one is 4 plus 8. We don't need the parentheses here. We just gonna say times 12. 4 times 8 is 12. So we have an equation. We have different way to solve it, but I think I will use the distributive property. And we have here 3x plus 9 equals 4 times 12, 48. Subtract 9. And we have 3x equals 39. And the last step, divide by 3 for finding x. Obviously, x equals 13, but we need to find d. Yeah, that is how much dE, because I call it just x. dE is 13. Let's take a look to part B, where we have a very similar problem. We need to find LB here. You notice LB is this segment, this chord. So we're going to start from point H, and you want to be very careful when you write the equation. So we're going to have HK, for example, which is 5, times HN. That will be 5 plus 2x, or I prefer to say 2x plus 5. I think it's better this way. Equal. So now we're going to move and do the same thing for the other side, and we're going to start from H. HB, that's is 3, times what now? And here you have to be careful. This is this 3 plus this 4x plus 4. So that will be 4x plus 7. Okay, so that's the reason we have here 4x plus 7. We add those two pieces. A distributive property, like in the previous problem, 5 times 2x, 10x. 5 times 5 is 25, equals 3 times 4x, 12x, and 3 times 7 is 21. I'll subtract 10x here. And we get here 25 equals 2x plus 21, subtract 21, and we have, I'm going to move here, 2x equals 24, I'm sorry, 4 only, and divide by 2, we have x equals 2. We're looking for LB, and LB, if you notice, is for x plus 4, so LB will be 4 times x, remember, we just found it, 2 plus 4. 4 times 2 is 8, plus 4 is 12. That is how much LB is. And one last problem in this lesson is this one. If you remember, we have this special case that I would suggest you to remember. We need to find the length of AB, this one, if AD is tangent to the circle T, and we notice also we have this BC is 9. So again, start from the point you have, point A, and we have AB. I'm going to start with this part, AB, that is x, times, now don't forget you have AC now, so that's the reason I'm going to write here x plus 9, because we add those two parts, the segment addition postulate, equals what? Now from here, AD, but don't forget to put square, right? Because it's AD square. So we have an equation, a quadratic equation in X. I'll use distributive property here. X squared plus 9X equals 36. I'll subtract 36 to make it a 0 on the other side. So we have here X squared plus 9X minus 36 equals 0. And here the best way I think is to factor out. We're looking for two numbers whose product is negative 36 and the sum is 9. The two numbers for which the product is negative 36 and the sum is 9 is 12 and negative 3. And then we have the factor form, x plus 12, x minus 3 equals 0, which gives us one solution here. X plus 12 equals 0 is give us x equals negative 12, which is not good because x in this case means the length, so we can ignore it. But the second one, x minus 3 equals 0, we get x equals 3, which is a good solution, and that x is AB. And that's it for this lesson. If you enjoyed this lesson, don't forget to click the like button and come back on C-Square for more help. Thank you.